We're going to talk about some of the things that are beneficial within that module extension today. We got a few slides that we're going to cover to talk about the company that is Boundary Systems before we get started today, and then we'll kind of dive right into the software and kind of proceed from there. So with that, we'll go ahead and get started with our little slide deck here, and I promise for the slide deck to be short and sweet, and then we'll get right back onto the software. Okay, so without further ado here, our agenda for the webinar here today will be obviously to talk about the Creo Advanced Assembly extension. We're having a little introduction right now, both to Boundary Systems and myself a little bit. And then we'll move on to the software demonstration. And at the end of the software demonstration, we'll leave time out there for some question and answer if we have some of that. I encourage everybody to use the chat functionality through your GoToWebinar interface and type your questions in to send them, or to arguably raise your hand for a question so I can unmute you specifically for the purpose of that question. We do have a lot of attendees today for this webinar, so it's going to kind of be important for me to keep the group muted as a whole so that everybody can hear me and we don't have a lot of over-trampling with respect to the sound and the audio through the GoTo interface. So again, when we get to the question and answer at the end of the session, please by all means, don't hesitate to use the chat functionality or to raise your hand specifically so I can search out for your name and then unmute you specifically for the purpose of the question. I thank you for your understanding regarding, handling the questions that way. Again, we've got a number of attendees today, so it'll make things better for everybody. Okay, so moving on, a little bit about Boundary Systems. Definitely one of the technology leaders in this space. A host of the clientele that Boundary Systems works with is shown on the screen right now. Some of the capabilities that Boundary Systems deals with directly are product lifecycle management, products and consulting, the same for data management, obviously CAD design and simulation as well in those spaces. Okay. Boundary Systems has been awarded numerous awards in recent history for accomplishments of the company and its success. Some of those awards are listed here on this page. Some of the solution systems that Boundary Systems works with are listed on this page. Okay, and for further information about the Advanced Assembly extension or other questions, whatever the case may be, you can contact our sales team at sales@boundarysys.com or myself. My email is listed there, and a link to some Advanced Assembly specific things is shown down here on the bottom of this particular slide. When we wrap up with the material on the software side, I'm going to go ahead and put this slide back on the screen at the end so that you get another chance to take note of this information. If you need to record my contact information or, for instance, the web link that's down on the bottom, I'll make sure that this is up on the screen for some more time at the end of the presentation that you get a chance to write that stuff out and take care of that as necessary, okay? So with that, we're going to go ahead and put the slide deck away. I did promise it would be short and sweet, and that is all of the slides that we'll be getting to. And now we'll dive right back into some stuff on the software side. Now, a little bit about, I'll speak just a minute or two here to a little bit of advanced assembly theory before we kind of dive right in. Some things that advanced assembly kind of addresses are kind of what I refer to as the 3 R's of assembly, and that's not a known thing. It's a Sean thing, if you will, when we speak to the 3 R's of assembly. And for me, those are replacement of assembly components, the reduction of assembly weight, or the number of components that I'm dealing with in the assembly and managing those components. What am I working on right now? What is most important to me? What do I not want to be carrying the weight of, visually and computationally within the system? And how I relate objects back and forth together in terms of managing references and shared information within the context of an assembly. So those are kind of like my little 3 R's of advanced assembly work. And we're going to speak to the nature of all three of those things today during this presentation. It doesn't cover the complete depth of all things that advanced assembly brings to the table, but I do find it to be very typical for folks to be heavily benefited by, you know, addressing those three functionalities that I just mentioned specifically: replacement, reduction, and reuse as it relates to assemblies, and particularly larger assemblies. Now, for the purpose of this demonstration, I've got some pretty small widgets that we're going to play with today. We're not going to use any 10,000 part assemblies because we wouldn't want everybody in the presentation to wait on, you know, the time and the weight on my laptop of managing files of that size and scope. However, the techniques that we'll discuss here today are applicable across the range of assembly size as it relates to part count, irregardless. So just the moral being, think to the technique as applicable to your assemblies, irrespective of their scale, given that they are quite likely to be much larger than the examples I would use today. But the techniques and the things that we'll do here will be applicable, and the workflows will be the same irregardless. Okay, so we'll start out with the first of my 3 R's today as it relates to addressing the 3 core things that we're going to talk about for advanced assembly extension. One of the unique things about advanced assembly extension is replace unrelated. Now, oftentimes, we prefer in design to use family cables and techniques that allow us to easily and quickly, without conflict or issue whatsoever, replace assembly components one for another. For instance, another person on the design team, you know, iterates the component into a new standard, and then we just take and swap that out with the family cable member. Away we go. Well, unfortunately, life isn't always that perfect, and not everything exists in the context of being produced through a family cable derivative. So oftentimes we find ourselves in the context of assemblies, be them large, small, or otherwise, where we need to go in and replace a component, but somebody created this component, shall we say, abstract from the assembly. It doesn't necessarily have information relating through a family cable or some other context to our assembly that we can take advantage of. Typically, historically, people would go through what would be arguably some pretty painful workflows to swap out these components, especially so when the component exists farther up the tree in terms of our history here within the software. The farther up in the timeline you essentially go for replacement operations, the higher the probability that you've got more child relationships stacked up on this object or component farther downstream, which can make that replacement, you know, arguably more cumbersome by far. So what we're going to talk about now is a replace unrelated functionality that is kind of a little, you know, maybe a little different to use on the face of it than maybe some of the other replace techniques that folks have been using. So our objective here is we're going to take this base component, the first guy here, for which everything else is basically related to. And you see, if I attempt to do a delete operation on that, I do in fact have, you know, the rest of these objects tied up to this base component in terms of some relationship or reference. So the significance of replacing the base component should be shown by that. So what we're going to do is we're going to go ahead and right-click on our component here, and we're going to go ahead and activate our Replace tool. Now, you've got a lot of options here in the Replace dialog. Something that we're not going to speak to in great depth today, but I share as a personal recommendation is whenever you're interacting with this dialog, in my professional experience, there's probably a 99% probability that you do not want this to be checked. Make sure that remembering these components is unchecked. That is the typical case. There are arguably always to be atypical scenarios where it would make sense to have that checked, but when you're interacting with this dialog, irrespective of what type of operation you're doing, generally speaking, it does behoove you to make sure that this is unchecked. So that is one of my first little observations when I interact with the Replace dialog, okay? So we validated that, remember, these components is in fact unchecked. So we're going to go ahead and say we want to do this as an unrelated component. not by copy, notebook, reference models, etc., but by unrelated component. That allows us to come over here and browse for the component now. So we come over here to browse for the component, and we're going to grab this circular base instead of the rectangular base that we currently have. So we go ahead and we grab the circular base. Now, this is the kind of tricky thing about replace unrelated. You don't get to edit this ref table. This does not come to life until you tell me what component we're going to go get. So it's important to follow the procedure in the kind of way it's being presented, because in order to get access to the reference table, the system has to know what both parts are. So the browse operation is required first, and that's why edit the reference table is grayed out by default. And I think a lot of people forego this functionality because it seems unavailable until they've kind of walked through the process in that way. So now we're going to go ahead and edit the reference table. Okay, and this is one of the, the elegant, very elegant things about replace unrelated. Now, what replace unrelated is essentially doing on some level is creating an interchange assembly for us on the fly. And it's another part of advanced assembly as it relates to interchange assemblies and such. And it exceeds the depth of what we're going to get into in this presentation today, other than to get it the easy way, which is what we're doing here to replace unrelated. Okay. Now, this interchange assembly system that we're working with here affords us the ability to basically, for lack of a better description, map or reassign things from the old part to the new incoming part as part of the replace operation, so that there aren't failures in the assembly and everything kind of updates predictably and cleanly for the engineer in question. Now, when we interact with the replace unrelated parent table dialog here, the reference parent table, the first thing you want to do is click Evaluate. Now, you can click Evaluate, and the system will automatically find what it can based on names and what it can based on internal IDs to the actual features of the part, okay? It is typical, and I say this tongue-in-cheek because I do not wish to encourage save as copy. Save as copy is typically not the best way to create derivatives. Family tables are arguably far more elegant, but arguably there are times and places in the world where save as copy is going to be how a derivative will be created of another part. When you do a replace unrelated in that context, the internal IDs that are not affected by change on the new component that was saved as a copy will be found automatically by these replace unrelated, pairing operations. And that's what we essentially did here in the Evaluate dialog that you can see. See, this has the same history. This has the same name. And it will go find those things automatically for you so that it optimizes the workflow of getting Part A mapped onto Part B for the replace operation. Now, I'm going to go ahead and cancel this because that's just, a little too easy, right? And it's arguably not going to be that elegant on all of your parts where everything is going to be found automatically. So we're going to pull the reference table back up in a condition that's unevaluated. Now, we know now that I can use this evaluate and get it to do everything automatically. Well, how do we handle this when we're not dealing with an automatic condition? Well, it's very easy, and it's part of the elegance of the interchange assembly on the fly here through advanced assembly extension, if you will, and that you can see it's highlighting the reference on this component. This allows me to just select the appropriate replacement reference on the other component graphically. And then now I can continue to highlight my next tag or reference, okay? And then that will highlight the next thing on the old component, which in this case is the right plane. Well, then I can drill into my component here in the tree and select planes and references directly as well through this interchange assembly interface. And then the last reference that we have in question here being this top surface of the part here. So we'll go ahead and select that guy over there on this part. And we say OK. Now when we're done, we get to say OK, Now when we come out and we've regenerated our assembly, everybody is mapped onto the new component. We don't have any failures. We don't have any problems. We have our green traffic light. Everything from a reference standpoint mapped over from one to one. And we didn't have the typical conflict of a lot of times people will grab their insert indicator and turn everything off and then replace the component and then bring other components and things back incrementally and handle the references kind of in a one-by-one method, if you will, or something for lack of a better description. And it's really quite cumbersome to work that way and to utilize some of the replace unrelated functionality when we're changing things in and out of assemblies. We're going through design iterations. A design iteration might be coming in from another engineer in another part of the company that didn't even create said derivative as the same as copy. Those can be difficult replacements if we have a number of references associated with the component, and using replace unrelated will definitely, hopefully optimize that workflow for the engineer. Okay? So that kind of speaks to the first of my 3 R's in the typical, advanced assembly things of having to replace components after the fact when we've got all this stuff in terms of references attached to the component. Replacing then, becomes a little bit more burdensome, obviously. So that functionality, I hope you folks find as much benefit from it as I do. Okay. So the next thing, we're going to go ahead and get rid of that stuff, move into a different folder here. And the next thing we're going to speak to today, specifically, is simplified representation. Okay. I'm going to open up a little engine assembly of a handful of parts here. We don't have a lot of parts on the screen, but we've got enough parts to speak to the overall topics of what simplified representation is and what the intent here is, what it does for you, and how that benefits you in an advanced assembly kind of way. Okay. The first thing, and I'm going to speak through this assembly in some context, if you will, as I go through this. Just to kind of give you some background to, some theory about why I might be doing the operation that I'm doing with the assembly in terms of simplified representation. So the first thing let's talk about is how the heck do I get to my simplified rep stuff, okay? There are 2 ways to access the simplified representation. The first thing, you can come to the View Manager from your View tab here under Manage Views, and that will activate your View Manager here as well. My personal favorite, however, is to access this directly from the In-Graphics toolbar in the Creo series products, which brings up the same thing without having to change around which particular ribbon tab I might be active to. Okay? So we open up our View Manager and we go to the Simplified Rep tab, and we see that we have a list of default reps here provided for us. Okay? These are kind of out-of-the-box representations that Creo provides for objects. Typically, in an advanced assembly context, if you will, the most typical representation states that you will be using are going to be the master representation state for an object and an excluded state for an object. And we'll get more to excluded as we go forward. It's worth noting that symbolic reps, geometric reps, graphic reps, light graphic reps, all provide for providing some display or information about the component, visually or otherwise, that reduces the impact of that component, reduces the price impact of that component on the assembly mathematically and graphically, okay? That we are going to dive into all of the different rep types and all of their different formulas and theories. This stuff is extensively well covered within the help system in Creo. However, it is worth noting that different representation levels, a geometry rep versus a master rep or whatever the case may be, will in fact have different restrictions. They may be visually unappealing. They may display the object in nothing more than a bounding box, or they may preclude you from taking measurements or extracting certain information from the object when it is in fact in that other representation state other than master. So typically, engineers prefer overall as a whole to have objects in the master representation state or otherwise be excluded if they're not relevant. Okay? So, as we see here, these are the default reps. We don't have one of our own yet. So let's say for talking purposes that our work today comprises, we need to do some things related to the internal part of this little engine assembly, relating to the crankshaft specifically, the connecting rod, and piston assembly stuff, to include the piston pin. We see in the piston assembly we have a pin, or excuse me, the piston, the pin, and the connecting rod itself. So we're going to be working with the crankshaft specifically and this piston assembly and for the work here. Now, part of what Simplified Reps do is, as I said, it falls under the reduce of my 3 R's. So we need to reduce all this other stuff. I don't want to be working and dealing with hiding and unhiding and messing around with all these other components, while my core focus today is going to be the crankshaft and its associated rotating assembly. So we go ahead and say we want to make a new representation. Now, like anything else, you're provided the ability to name the rep on creation. I'm just going to call this rotate today, and you hit your enter key. Now, the new simplified rep creation dialog appears. Okay. Now, this dialog provides for a preview over here of what objects will be part of this simplified rep and what objects won't be. The preview is blank because by default, all the objects are off. The simplified representation chooser is asking you to tell you what you want, not what you want to get rid of. Okay, we'll get to that here in a second. But the default condition is, what do I want to work on? Okay, not the question of, okay, I have to turn the whole assembly off. The assumption here is you want a few things from a pile of a lot of things. Okay, pardon me, excuse me. Now, in our case, we know that I wanted to work on this piston assembly and the crankshaft. So I'm going to hold my control key and select both of these objects. You see that we have exclude derived listed as the actual representation level for these components. We're going to right-click on these guys now and set their representation to be master. As soon as I do that, my preview is updated over here, and the preview supports zoom, pan, and rotate, and space mouse related controls as well. Okay. As soon as I do that, there we see I have the rotating assembly up. Okay, and that would otherwise create that group of parts for me to work with. Now, as I said, when we entered this dialog, the condition here is you're being asked what you want. Now, in acknowledging the reality that sometimes the selection is better the other way, meaning I need to tell it what I don't want, if I would have entered this dialog and that had been the case, all right, I'm going to switch these back into the representation to be derived now, and this would have been just like we saw the dialog when we started. I need to check this box up here. If I check this box up here next to engine assembly, you'll see that it switches everything into the master rep as being derived. Okay? Now, the default case is objects will be included, not excluded. So if I wanted to eliminate the same rotating assembly, I can now select those same components here within the dialog and set that representation to be excluded. And then I would have the externals of this engine and not the rotating assembly that we spoke to initially. So be aware that the selection formula works both ways, but by default, it's a question of pick what you want to keep, in which case we're going to come in here and put these in the master rep. Pick what you want to keep or what you want to work with, as opposed to having to select everything to turn off. Now, again, we arguably, typically, want to have these objects in the master rep because we might intend to do things with them. And the master rep is the typical universe that folks are used to working in so much as that it doesn't provide for any restriction. There isn't any visual scaling back, as I mentioned, and there isn't any geometric scaling back of the object either. It's fully available for the context of modeling everybody knows and appreciates. setting these particular objects to be a different representation, graphics, geometry, something other than master, would potentially reduce my ability to interact with them. Now that goes without saying that maybe I want to keep something visual on the screen. Maybe I want the muffler to be set up in a symbolic or a graphics rep or a geometry rep. At the same time, I have the rotating assembly in the master rep. And that's completely legal, and that's just fine, and it will be stored as part of the context of this simplified rep that we are creating, okay? So, but in this case, we're just setting these two objects here to be the master rep. Now, sometimes you might have a really big list here, you know, and it might, let's just say, let's just say, for instance, it would be, I know what the crankshaft is visually, but I don't know the name of it in the list, right? Maybe you're dealing with abstract part numbers where they're being randomly generated as alphanumeric, alphabet soup stuff, where it's not so easy, where, things are called a crankshaft, but you still need to get that component selected or dealt with. The selection method up here affords you the ability to do that. We can then select in the main window and elect to select an object right here. Now I've selected the crankshaft in the main window. And then when I say OK and I come back, the crankshaft will be selected in whatever list is provided here. So again, I acknowledge that I'm working with a very small assembly today, and that, some of the typical problems that we might have just with the nature of enormity with part count don't exist and might not be obvious on the face here, but I do want to speak to those things nonetheless, which is why I show here that you can definitely derail, come in here and do a select in the main window to get the object selected here in the simplified rep chooser. If it doesn't, if it isn't, as easy to just make the selections alphabetically, if you will, here. So we'll go ahead and set this rep to be a master for the crankshaft as well here, okay? And we're going to go ahead and say, okay. Now I've got just the rotating assembly that we decided I was going to work on, or that I needed to work on for this assembly. Now that's what's present on the screen here, okay? In terms of what I have to work with visually. So we'll go ahead and close this. Now, at the end of the day, when we teach this in class, I always have a lot of folks ask me, well, that doesn't arguably seem a lot different than just hiding the object, Sean. I can just come over here and right-click and hide some object, and it goes away visually. And I don't have to go to all this trouble of messing around and creating this, simplified rep. The simplified rep is bigger than hide in two formal ways, okay? Typically, when we see a lot of people do a hide operation, they're going to come back very soon, and they're going to do an unhide operation on those very same components. And you spend a lot more time typically when you use that workflow than what is often given credit for doing hide and unhide, turn all these components off and then turn them all back on and all that type of stuff. And you end up, switching in and out of states a lot more than you think. So on the face of it, taking the time to create the state that is this rotating assembly, so I can just switch back and forth, has a big benefit. Now I can come in here and just double-click and say master, and I'm right back to looking at and working with everything. And then when I need to go back to my rotating assembly, I can pull up my view manager and just turn my rotating assembly back on, and I'm not hiding and unhiding a ton of stuff. And I know what some folks, the sharp users in the room, are thinking. Well, they're saying to themselves, Sean, that's not arguably wildly different than if I create a layer state and I hide those objects on that layer in the assembly. And I acknowledge that up until the point where we talk visually. I can do a layer state in a very similar way visually. What the layer state doesn't afford me, and what is intended to speak to my second R in the 3 R's of advanced assembly, which is reduce. One of the things layer states and hide and unhide over here on the tree aren't going to do is reduce the mathematical footprint of the component and the assembly. Because I have put this in a simplified rep, I'm afforded the ability now to come up and do an erase not displayed. So I can say File, Manage Session, Erase not displayed. Now notice that all of the objects that are in my assembly that are not part of this rotating simplified rep, that information is extra to some degree now. And I can essentially say, okay, in all of those objects, and the weight and regeneration and the heaviness of them has been removed from the system mathematically. This is where we cross over to the next level, above and beyond hide and unhide, whether that process is done through a formal layer state or that process is done directly interacting with the tree. Hide and unhide in the context of advanced or large assemblies and advanced assembly techniques, it cannot take you there. It cannot get rid of the graphical, or excuse me, it can get rid of the graphical penalty for a part, but it does not get rid of the mathematical penalty given by a part. So in this case now, I've got my little assembly, and I know it's very lightweight because I've put away all the information that was not being used on those other components here outside of my rep that we created. So now when I've got a simplified rep, we're going to go ahead and save this assembly off real quick. Whoops, do a save on that. I'm going to go ahead and close this and then erase the whole thing out again. Okay. Now we're going to go ahead and open that again. All right. Now, one of the powerful things about creating a rep is, in creating a representation, it's got a lot of follow-up support that, you know, simple hide and unhide doesn't give you. Now, the follow-up support being, on my open here, I can open a representation that is previously created. So when I come back and I went on vacation, I got to come back next week to my, you know, my rotating assembly work, and everybody else has been working on this assembly, and the whole assembly still exists. Well, I don't have to open up all their parts and deal with all that. All I need to do is come in here and say, I want to come back and open up my representation that I previously created in the file set. Now, I can then extract that representation that we created and put that on the screen. And I don't have to open up the entire assembly. Now, the other cool thing is, in the context of open, as it relates to all things simplified rep, is sometimes that's not already going to exist, right? You know, in this case, we created a rep, we did our thing, and, you know, then we went back to it. Well, maybe I need to do this, but that rep isn't previously created for me. That's the context of open subset, okay? So, and this kind of plays into the context of advanced assembly as well. Oops, and I got the blower assembly. My apologies there. So let me get back to my engine that we were dealing with. There we go. So we're going to open a subset from our engine. Now we grab the engine, a open subset, and if this looks familiar, it should. It's arguably pretty much a similar theory to what we just dealt with in the simplified rep dialog. Now what we're going to do is we're going to select our piston assembly that we know we want and our crankshaft that we know that we want, and we're going to right click and we're going to say we want to retrieve those guys. And you see how they kind of become, you know, they're no longer the blended dimmed down transparency. And we basically say okay. And we've opened this up. And now I didn't have to pay the price to go get 10,000 parts when I need to work on 6 objects. I only had to retrieve the specific objects that I want to deal with in the context of this assembly. So I've done a reduce on the face of it. Before I ever even got involved in this assembly, I did the reduce operation rather than having to do part of the reduce operation as I'm working along. However, doing the reduce operation in the way that we first demonstrated it, by putting these things away as part of a workflow within the assembly itself, can continue to keep your assembly very lightweight as you work on it, as opposed to letting it continue to grow, if you will, and keeping all of these objects, even after you've gone down the course of creating an object, essentially finishing that object at that stage, and then moving on to something else, it's nice when that object that you've otherwise now just finished, if it's not necessary for the continuing of the process, to have it go away as well within the simplified rep. Okay, so we've kind of retrieved this now. Now, the beauty of this is it's already ready to be a simplified rep. So if it didn't exist as a simplified rep, I had to open the subset and essentially create this rep by retrieval. I'm ready now. These are my parts. This is what's on my screen right now. And you see how my master rep gets the little plus key here? Okay, it knows that the master rep in this state is kind of like, modified, and that's not gonna end that way, because you're not going to effectively modify the master rep. I can save this off as something else, but the master rep is going to be the master rep for this assembly, which we're not really in right now because we opened up the subset. So I'm going to right click on this guy and I'm going to say save, and we'll just give it the rep 02 today, and we'll give it a number 2 here, and we'll say okay. So then it just creates that simplified, it just saves that off as a simplified rep. So then I can switch back to my master rep again and bring back all my parts, or I can go to my rep 02 that we created, or that rotate rep that was still laying around within our assembly. Okay? So again, you can retrieve things into a reduced state by using open subset. You can open previously created, I'll just turn the silly preview off there. You can open previously created representations directly as well to reduce the weight and the involvement of what you're working with within the assembly. And then you can go right back to where you were, essentially, and again, now I have to put 10,000 parts on the screen to be needing to work on a handful of them or whatever the case may be today, okay? Now, one of the other things that is kind of valuable here, and I'm going to open that assembly up real quick one more time and do a quick demonstration here as it relates to getting some use out of this. So we've got, we know that we went and we created this rotate representation here, right? Well, what else can I do with these reps? Well, in the context of assembly, you've kind of filtered the assembly down to this. So you might need to collaborate about just those objects, or you might need to document just those objects. When that is in fact the case, okay, we can use our simplified rep to speed up some drawing sign creation process stuff, okay? And we just got a simple template here. We're going to turn off all that stuff, and I'll go ahead and put a new view in here, no combined state, and we'll just take that view right there, okay? Now, one of the cool things that you can do is, your view state can select that representation that you have created on the drawing. So I'm going to apply that rotate simplified representation in the context of this assembly drawing, and now I just have that rotating assembly in this particular view. So you get a benefit downstream all the way to drawing documentation from the strength of simplified representation. Okay? All right. So that speaks to some stuff about simplified reps. So now let's talk, and we're going to go ahead and open up our little assembly here again. And get the engine back on the screen here. Okay, so let's talk to the third of my R's on this theory and situation here, which being the relate concept, relating or sharing information between parts within an assembly. Okay, typically we see a lot of people that oftentimes go ahead and just activate a component here in the assembly. They activate, and then they go start picking references on whatever other stuff in the assembly without giving consideration to what the timeline is or how to elegantly manage this puzzle that is being created by that workflow. It doesn't always end well when we use those techniques. Okay, so there are better ways. And we're going to kind of speak to two things now. We're going to speak to the context of what we call published and copied geometry and skeleton model. And I'm going to tie these things together in a way here a little bit as a little part of the demonstration here to kind of give you some idea of how we might go about this relate part of my 3 R's for assembly. Okay, so the first thing we might do is create a skeleton model, because a skeleton model is a nice advanced assembly container to put all this information into, okay? So the way we create a skeleton model is using create. You don't assemble a skeleton model. You build it in the context of the assembly. So we're going to go ahead and say create, and the type of component we're making today is going to be a skeleton model. So, and then as always, we're going to be prompted to come up with a name that's appropriate for our skeleton model. So then we have the creation options for the skeleton model, and we can use a specific template for the skeleton model. And in this case, I'm going to go browse and get my specific skeleton model template that we'll be using here, okay? So I have a skeleton model template, and I go ahead and open that up. Now, when I do so, you see that a special kind of icon is created right underneath of our engine assembly here, right at the very top, okay? And I have my skeleton part here. One of the, this part is non-negotiable. It does not move around. It is not reassigned positionally or anything in the assembly. It has the unique, property of being the first object no matter what and being regenerated first because it is the first object in the tree. And because of its context that way, it's given a unique icon up here in our feature tree. Now, let's just say for an example purpose that we need to share some information, okay? For the purpose of what's going on here, let's just say, for some reason here, that the little carburetor wants some particular information from the muffler, okay? And again, I could activate the carburetor and then share that information in or whatever the case may be. But we're going to do the more appropriate advanced assembly technique today. So what we're going to do first is we're going to activate our muffler, okay? And we're going to say, okay, on this muffler, I need this outlet diameter. I need that surface to be inside of the building of my carburetor part so I can create a relation to a dimension from this outlet diameter to work with, mathematical information within the context of my carburetor, for instance, okay? So we've activated our muffler part. We're going to go over here to the model intent group, and we're going to select publish geometry, okay? In this case, I can grab change, references, or surface sets. Now, in this case, for our example, I'm just going to grab this as a surface that I would then put a known dimension on in the context of the carburetor to utilize that dimension from the muffler, okay? Without accessing the muffler directly, if you will. So I'm going to go ahead and grab that individual surface there on my little publish geometry feature, and I'm going to go ahead and say, okay. Now, a brief thing about publish geometry is that this can work exceptionally well also in the context of large groups and large assemblies. Say, for instance, in the automotive context, say the people that are working in body and chassis and the people that are working in interior need to share a lot of information, but it's very unlikely that the interior guys want all of the chassis information. They're likely only interested in information as it relates to where the seat is mounted, formally to the body of the car or something to that effect, rather than show me the whole chassis. This affords the chassis engineers the ability to publish out just that information that is relevant to other downstream or other users that are connected in the assembly process, so that the chassis guys can go grab the interior guys can go grab a published geometry feature from the chassis guys that doesn't have the whole chassis in it. It just has these pieces of information in it that are significant to what the interior people might need. So again, we're dealing with small context, small examples here today, but always remember these things are intended to be extrapolated onto a much bigger level for larger groups and larger assemblies, okay? So we've otherwise created our little publish geometry feature here within the context of our muffler part. Now, the other thing that can be done here, I'm going to go ahead and delete the publish geometry out of the muffler part. Now, typically, then the carburetor would have came and looked at the publish geometry from the muffler part. But what we're going to do today is a more appropriate skeleton model. So in this case, I'm going to activate the skeleton model and publish the geometry. Oops, excuse me. I apologize. I got my process back up there. So I need to put my published geometry back there, and I need to access my published geometry from the skeleton model. My apologies. Okay. So let me get that back into my muffler part. I kind of got ahead of myself there. So, and we'll put our published geometry back in there. Okay. So there we go, and now we'll reactivate that. Now what we're going to do is access our published geometry feature from our skeleton model that we'll put back in the part. Okay, so we'll go create our little skeleton real quick, and I'll just use that as just use the default template for it in this case to kind of recover from my mistake here. Okay, so now we're going to activate our skeleton, and we're going to copy geometry into it. Okay, now by default, this checkbox or this control says we're going to go get published geometry. Okay, so now it's looking for a published geometry item. So we'll go get that from our muffler. Okay, now we've got the published geometry selected from our muffler that we created. Now in this case, when we open our skeleton part, we see there is the surface that came in from our muffler. And now I can use and create this, or excuse me, I can create information as a derivative from this copy geometry feature within my skeleton model. So when it comes time for my carburetor to make use of that, and I'm working in my assembly here on my carburetor, what I would do is access that information not from the muffler, but in this case, I'm using the skeleton model as my container to make sanity of where all these objects are. I mean, you could have published geometry features throughout a host of assembly components in a very large assembly, and it can get very daunting. It's just where are all these things and how are they being managed? The skeleton model affords us a nice, clean container to pass this information back and forth without having to get involved in remembering or noting or dealing with the direct part-to-part relationship where those things reside exclusively between parts, as we mentioned initially. So in this case now, my carburetor, while I'm in active mode, working on the carburetor in this assembly, it would access this piece of information from this copy geometry within my skeleton model. This will also afford me the ability to make design changes as it relates to, like, let's say, for instance, I'm here within my carburetor part, and I'm just going to turn the muffler off real quick for a second. Okay, I'm in my carburetor part here, working away, and I want to utilize that surface for some piece of that geometry, that copy geometry on my skeleton. I have no problem dealing with that. Okay, and we'll unhide all our surfaces, and somehow unhide everything here. And let's go to the assembly here. And go to top level, and let's turn on all our surfaces here. There we go. And now we got our surface back. So I can hide the muffler out, but nonetheless keep that surface that I just want to use to create maybe a sketch within the context of my carburetor. So maybe I want to have a sketch in here because I want to extract the information of that diameter or something and put that into a relation. So I might come in and, actually make a sketch for it and then access this number within the context of a relation to derive something here within the carburetor part. When it's all said and done, when that process is all said and done, simply hide out the surface of the information from the carburetor part, from the skeleton model, and the surface is hidden from the carburetor part, but the information is not, if that makes sense. Okay? So that gives us the ability to kind of pass back and forth a little bit to speak to the relate context of the 3 R's of, advanced assembly. How do I relate information between all of these different, components within a demanding assembly, if you will? Copy and publish geometry, give you a clean, dedicated way to do that where specified references are available. The other implication that comes from this that I'll speak to just quickly is by utilizing that context, you are afforded, I've opened up my skeleton model that has the copy geometry feature in it. You are afforded in the more recent builds, in the more recent versions of Creo, you are afforded direct right-click update control for that as well, which can be kind of slick. I think it's kind of nice and handy to be able to have it, control it that way myself personally, so that maybe some objects I do even want to do a no dependency on, or some things are going to have a very specific update, universe where maybe I want to set those to be a specific manual update or whatever the case may be. So it's kind of nice that, now in the more recent versions, we've got that right on our copy geometry to be able to handle the update control right there as a right click as well, which is also, kind of nice functionality in the spirit of all things advanced assembly. So that speaks to the relate part of my 3 R's for assembly here today. We've covered replace, reduce, and relate as 3 of our primary topics here. With that, I'm going to go ahead and put my contact information back on the screen, and Boundary Systems contact information and the link that had that information for advanced assembly. And I'm going to keep the floor open for the remainder up here until 12:30 for questions. And again, please don't hesitate to type your questions in through the chat functionality within the GoToWebinar, and I'll get right to those. Or alternatively, you can raise your hand, and then I'll, like I mentioned earlier, I'll unmute you specifically, and then we can get the question asked and proceed from there. So with that, like I said, I'm going to go ahead and put that slide information back on the screen. I want to thank everybody for your time today specifically. I appreciate your attendance as well as those Boundary Systems, and thank you for the opportunity to talk about some advanced assembly stuff with you here today. So with that, I'm going to go ahead and keep this contact information up on the screen and keep the floor open for the remainder up here until about 12:30 or so, maybe a few minutes after. And if you folks have got any questions, please get them out there on it, and we'll do our very best to speak to those questions.
Hey, Sean, this is Wade. There are several questions in the questions section that you can take a look at. One of them that was asked about the copy geometry was using the copy geometry from the Muffler. Is it acceptable to bring the references from the top assembly? And that was from Claudio. I'm going to unmute in case you need clarification on that one.
Okay, run that by me one more time, Wade. I'm sorry. I'm just getting all the questions. I had to expand the question panel and pull it out because the text was just bloody small.
It's the second one from the bottom about using copy geometry, if you want to read it.
Okay, we have a question. Using the copy geometry from the Muffler, is it acceptable to bring the reference from the top assembly? Okay, so let me get my assembly back on the screen to kind of speak to this here, okay? It's obviously possible to do that. Now, is it acceptable? I would say that's, in some degree, there can be some company standard in play here and what's acceptable in your environment. The caveat that I place on the end of this being is that when you're just dealing with it in the top level assembly, you oftentimes have to be very conscious of part design development order. Because when you're handling the reference directly at the top level of the assembly, you can become trapped, for lack of a better description, about the order under which parts occur within the assembly timeline. Whereas utilizing a skeleton model and passing this information through the skeleton model, et cetera, as we're doing here, does afford me the ability, as you can see, I'm dragging and dropping the components around in the assembly. It does give us the ability to not be so concerned with some of those issues. So Is it acceptable? That might be a little bit of a loaded part of the question. At the risk of a cop-out, I would say it's somewhat maybe less elegant, and it is something that maybe should have some caution to it with respect to, utilizing that technique, because it is easy to get into a circular reference trouble a little bit more so, I believe, when it's being done with that kind of workflow. Okay? Another question on the list. By publishing geometry to the skeleton, aren't you creating a circular reference? The idea is that we want the information to be regenerated sooner than when it's required, if you will. The skeleton model will be non-negotiably the first object regenerated in the cycle, and it will validate its geometry by part of that process. So unless it's possible I'm not understanding that question in the correct context, but I don't feel that to be a circular reference problem. For some assembly, another question. For some assemblies, we have features at the assembly level. Using a different representation of the assembly, the cut features at the assembly level will disappear. Do you have a different workaround for having cut features at the assembly level plus the simplified representation? Assuming on the face of it that the advanced intersection control is being utilized to make that assembly level cut available at part level, if that is in fact being used in the context that we're speaking to in this question, where during the assembly cut we're utilizing the advanced intersection control and we're setting that to be part level, and it still disappears those parts through the simplified rep environment, I would say that I probably don't have any formal workaround that would deal with that, and it's simply following the parent-child relationship structure to the best they can under those circumstances. However, I want to say that, at least from, and I can't validate this right this instant, but from memory, in my own experience, I want to say when those were part-level assignments for the cuts, I was able to keep them from a simplified rep, or keep them within the context of a simplified rep. But my memory could be faulty there, or things could have changed in the system, and that may not be possible. But if that's no longer possible, if you will, to deal with it that way, then I would argue, unfortunately, my news is bad today, and I probably don't have a good workaround for the context of assembly cuts plus simplified representation. Another question we have is, using a family table, is it a best practice? Most of the customers that are using Windchill is not to use a family table. How about interchange assemblies? Interchange assemblies, yes, by all means, are very much encouraged throughout the system. Typically, my understanding is a lot of the pushback on Windchill as it's related to family tables historically was more so problematic in the context of nested family tables. When a family table instance becomes a generic for another table. I am aware of some historical problems as it relates to Windshield with that. I'm not aware in the more modern sense of reasons in a broad scope why folks wouldn't utilize family table functionality under a Windchill environment. Now, I caveat that with the broad scope statement because Windchill environments are inherently very unique in their deployment, in what's needed, in the way that they're, operated, for lack of a better description, company to company to company. So I don't know that it fits everywhere, I guess is the simple answer there. But on the face of it, I would encourage somebody that wants to use family tables to kind of explore that rather than maybe, just on the face of it, part and parcel, write it off to some of maybe what was a historical issue that wasn't possibly directly related to the Windchill implementation they might be working with. I feel like there's probably a lot more fit for family tables for Windchill users than not, but it's one of those things that's been historically spoken about enough that there are reservations there. But
Sean?
I'm
Hey, Sean.
Windchill employee. I can't speak to that.
Hey, Sean, this is Wade. Can you hear me okay?
Yeah.
Just to add a little bit to that, one of the big issues with family tables, and this plays into what you said about nested family tables, is the fact that there's only one file in Windchill. It creates an object for the generic that contains the file, and it creates an object for each of the individual instances of the family table that are all related to that generic. And anytime you want to make a change to an instance, or you want to add a new instance to the family table, in Windchill, you have to modify the generic because that's where the file is stored. And where people get into problems is where they are using, obviously, nested family tables, because now we have multiple levels of generics that all need to be checked out and modified to change a bottom level instance. But also if people have used the generic as a component in an assembly. And so that's one of the key things is you can very much use family tables successfully with Windchill, but you want to have planned out your strategy for how to use them and know what you should and shouldn't do in order to do that. The problems occur if people have created a part, used it in an assembly, and then later decide, oh, I need a similar part, so I'm going to go in and create a family table and create some new instances, but I've already used what's now the generic as a component. Now, anytime I want to change any of the actual instances of the table, I'm modifying a component that's actually used in assemblies somewhere, and I've sort of lost, some of my rev control and things like that. So that's where if you started out, you already had a standalone part, it was used in an assembly. If you're using Windchill, it's a better practice to create a copy of that and then make them interchangeable through an interchange assembly or something like that. If it's something that is going to be a family of similar parts, you can set it up front as a family table and just know to never use that generic as a component.
Okay, a little bit of additional information about Windchill. Obviously, some things as it relates to family tables and Windchill are very important. Not using a generic in the assemblies that would be managed by Windchill being a very significant part of working with Windchill and family tables. Understanding that implication and planning for it in your design cycle to better make the determination. Is it better to approach your designs with interchange assembly or family table? Has a lot to do with, thinking through those implications early on in your design cycle. And for sure to make certain that deployment of a generic within the assemblies themselves is arguably never really the ideal, workflow. More so the case for sure in the environment of Windchill, that we would definitely want to avoid deployment of generic part files, or generic files from a family table into assemblies that would be Windchill managed. So there are a few concessions in that, but other than some of those things, Windchill and family tables is very much a workable solution for folks, and encouraged, provided that the proper considerations and planning are done up front for how that environment will be managed. Okay, more questions. Okay, I'm going through the list to see if I can see anybody that's got hands raised. I've spoken to the questions that I have on my list at the moment. If somebody's creating a question, by all means, I hope to be able to wait and catch that question. Don't hesitate to type in a question through the chat window as well if you do have some. I've got a little bit better view on my go-to screen now that I should be able to see questions coming in a little bit better. Okay, question comes in. Do you have any WebEx related to module product or module configurator? I'm going to go ahead and unmute the attendee asking the question. because I think I need a little bit more context on the question. I might not properly answer that without a little bit better information. So I've gone ahead and unmuted the attendee that asked that particular question. So go ahead and ask me the question verbally now, and let me see if I can speak to that. You may have to unmute, or you may have to turn up your speakers or something, but I do have you unmuted now.
Hello? Hello, can you hear me?
Yep, we hear you.
Hi, my name is Claudio, and I have a question. Do you have any WebEx session related to module configurator or project configurator? Is something new modules that appear starting with Creo 2, Creo 3?
That would be the Creo. I'm trying to remember the name of the product. The options modeler.
Yes, yes, you're right. Yes.
I don't believe we currently have any on the schedule for that. We have done that in the past, and so if you are interested in that, we can get one on the schedule, and we can also have somebody reach out directly to you if you're interested in it sooner than that, and schedule a one-on-one demonstration for you if you would like.
Oh, perfect. Yep. Thank you. Thank you.
You're welcome.
Okay, again, more questions this afternoon. Good questions, and I thank everybody for them. These webinars are a lot better when we get a chance to interact with folks and get a chance to speak to their questions that the webinar may have generated.
Hey, Sean, do you want to just put the contact info back up there for one more minute before you end the session?
Sure. Okay, we've got contact information back on the screen, folks, and we'll keep this up for another minute or two here, and then we'll probably be closing up here maybe about 20 till or so. Yeah, but by all means, keep the questions coming in. If the remaining attendees have any questions, don't hesitate to ask them at this time.